Bob Marvini, who is state geologist with the Maine Geological Survey, which is part of the Department of Agriculture, Conservation, and Forestry, whose commissioner is here right now. So Bob, why don't you come up as co-chair of the Science and Technical Subcommittee and give us an introduction to what we're about to do.
All right, good morning, thank you. My co-chair, Ivan Fernandez, of the Science and Technical Subcommittee, well, we did rock, paper, scissors to decide who got the honor of presenting here, and it's pretty obvious what I threw. I guess he figured that out somehow. Anyhow, thank you for this opportunity to introduce the work of the STS, as we call it. I have been very impressed with the people on this committee, their dedication, their knowledge, their depth, their willingness to just dive right in and do some very, very hard work. The committee has met on several occasions since October to work on what we've called a Phase 1 working document. And this is intended to be a summary of it's an initial summary of trends and impacts of climate change in Maine and in the region. And I'm glad that we have such talent in this committee because they've really pulled together a lot of information. The committee, this document will be available probably within a week or so on the Climate Council website, so it'll be publicly accessible. If you don't have time to read the 282 pages in its entirety, I hope you'll at least read the highlights, which really are really capture the breadth and depth of this document. And we will continue to work on improving. This document was intended to provide some really important information at this stage to the work groups so that they are working with some really good scientific background as they look at what policies might be important in their particular disciplines. So we wanted to get this out at this time so it would be useful to the work groups, but we're going to continue to work on this and produce a Phase 2 report that would be incorporated into the final action plan for climate change that we'll all work on through the coming months and make that final by December. So we're continuing to work on this effort. Today, we'll have 6 presentations by members of the committee on various disciplines covered by our committee and that you're all working the policy aspects of. And let me just say that each of the 6 has 15 minutes to talk, but they could easily, each of them, take up the entire 2 hours. So it's really a brief summary of very important information that will be in this Phase 1 document that will be available to all of you shortly. Many members of the committee also will be here for the afternoon to participate in the work group discussion. So please take advantage of that when we all break for those very important discussions. So without any further ado, let's get going with the presentations. Thank you.
Excellent. Thank you very much, Bob. Yep. Okay. All right. So the first one is going to be climate, right? And that's going to be Sean. And I'll ask you to introduce yourself. As Bob mentioned, I have a limit on 15 minutes for these. Gassie's here, and has some helpful reminders when you got 2 minutes left and 1 minute left, all right? And we might all see that, and we can all help too, okay? I also just want to note, I think we have a lot more members of the youth organizations here right now. And can you just raise your hands if you're here with the youth organizations right now? Okay, awesome, thanks guys. Fantastic, right. Okay, I also understand that many or all of you will making some graceful exit at some point during these presentations. So I understand, as Hannah said earlier, that's because they have another activity they need to go to. It's not walking out of protest, we hope. Okay. All right, Sean, if you can introduce yourself, and you're off to the races.
Well, good morning, everyone. I'm Sean Birkel. I'm a research assistant professor at the University of Maine Climate Change Institute with a joint appointment at the School of Earth and Climate Sciences, and I'm also the Maine State Climatologist. And I'd like to thank the STS co-chairs, Bob and Ivan, and also that this presentation that I'm about to give, it's the combined work of others on the climate group within the Science and Technical Subcommittee, Bradfield Lyon, Glenn Hodgkins, Pan Lombard, and also Representative Brian Hubble, who provides some valuable insights. And so it was a group effort, and it's been a pleasure to work on this, and I look forward to continuing our work and improving the document that we've already produced. And so having said that, I can now move on to the presentation outline. Our climate group, we had several different topics that we wanted to include in the document, and so I just want to give you a sense of where we'll be going for the next few minutes. So first, I'll have a brief discussion on the temperature impacts on Maine's climate, how the length of the seasons has been impacted, impacts from precipitation and drought, how that's changed in recent decades. Extreme weather, that's something that we've just recently, in the fall, so a couple of pretty significant storms, very impactful, that certainly linked in here. Also snow, changes in snow and hydrology, and then a summary. The statewide mean annual temperature, this is temperature averaged from data collected across the state. Reliable, continuous measurements go back well more than 100 years. NOAA has data sets that have been compiled that began 1895 and provide us really detailed information per climate zone. There are 3 climate zones in Maine, the coastal, central, and northern. In the time series that you see here, looking at the past just over a century of temperature data, we see there's been an overall increase in the mean annual temperature of 3 degrees Fahrenheit. And you'll note that there's quite a bit of structure in this curve. There's both what we would call interannual variability, that's year-to-year changes, and also decade scale changes, but the overall trend is upward. And models that have been constructed over the past decades that they've been produced to project into the future how the climate system will respond to continued increases in greenhouse gases. And also factors such as aerosol emissions and changes in land use that affects the surface reflectivity of the Earth. Those models have been run in a series of simulations testing different scenarios of socioeconomic development, and that, of course, impacts greenhouse gas emissions. And so the figure that you see here, it shows the historical record of temperature change in Maine in black, and the colored lines, those are the different scenarios of effectively emissions. And from these models, we find that for Maine, the projected warming out to the year 2100 ranges from 2 to 10 degrees Fahrenheit, depending upon the emission scenario, so the global effort. Whether or not the low emission scenario pans out, which probably have opinions on if that's likely or not, versus the very high emission scenario. But that is the projected range, 2 to 10 degree warming from recent conditions. And so that in itself, quite impactful. And I want to speak a little more about the climate models that are used to project out into the next several decades. They're calibrated against the historical observations. And so in order to have faith in a model, we need to make sure that it can pretty well match the historical record. But we can also conduct simulations for the historical record in which greenhouse gas emissions are held are held are not a factor, in which the concentration of CO2 in the atmosphere is held constant, and we can find from the models how the natural system would respond. And so this figure here shows two scenarios compared to observations in black of global mean temperature, and we find that the scenario in which the climate is warmed by greenhouse gas emissions, that's in red, and the natural only forcing simulation from volcanic eruptions and solar variability, that's in blue. And I like to make this point that between about 1930 and 1960, that's when the human-caused impact really began to emerge from the noise of natural variability. So the warming, the significant warming that we've seen since at least the 1950s, 1960s, that signal can be attributed to greenhouse gas emissions, very, very certainly. And here in Maine, we've noticed increasingly more and more changes in the climate getting very impactful since at least the 1980s and certainly into the 2000s. The season lengths, this is very much connected to the increase in mean annual temperature because it affects the monthly progression of temperature throughout the year. And this, of course, ties into the growing season. And so the major point here is that summers are getting longer, and over the past century, they've increased by about 2 weeks in length, and the winters are shorter. And the projection going out several more decades, there should be at least another at a minimum, another 2-week lengthening of the summer season. When I say summer season, I really mean the warm season. But also this parallels the growing season. There's been a documented increase an estimated increase in the growing season since 1950 of almost 16 days on average statewide from daily measurements of temperature. And so the temperature increase, it's not just the annual means increasing, but it's really how it's impacting the annual cycle. The relative length of the seasons, winter's getting shorter, summer's getting longer. That impacts natural systems and impacts agriculture. And so you can see that from this figure. It just shows how the signal is changing. And I also wanted to mention that part of the warming climate, much of it, if not most of it, is in the increase in overnight low temperatures. So that's one thing to be mindful of as well. It's not so much that the high temperatures are increasing, they are a little bit, but it's really the overnight lows. There's more moisture in the atmosphere now because the oceans are warming. Precipitation and drought. Maine is getting wetter on an annual basis overall. There's more total annual accumulation of rainfall. And over the past century, that increase is about 6 inches. And the last decade and a half has been particularly wet, despite the moderate drought that set in for a couple of years. But you can see that there's an overall trend of increasing wetness in Maine. That's true of the Northeast region as well. And the climate models also project that our region should continue to get wetter. Now, that's on an annual average. There's also a change in higher frequency events in terms of extreme precipitation events, heavy rainfall events that we've been experiencing. And I'll talk more about that in the next slide. But first, drought occurrence, especially after the 2016-2017 drought, very impactful. Many wells went dry. And so there's always concern, well, in a warming climate, might there be more intermittent drought or seasonal drought? And that's uncertain. Projections aren't clear as to whether or not that will become more or less of an impact. However, with increasing summer temperatures, that will tend to exacerbate any drought that does occur. So that's another thing to keep in mind. So even though overall our region should continue to get wetter, and there's still the other concerns that go along with that. Extreme weather. Certainly in the past 10 years, I think we've all seen some somewhat, well, if not unusual, but definitely the increased amount of heavy rainfall events. It's something that a lot of people have just noticed. It seems like it rains harder for longer. And the data do support that. From daily station data, we find that in the last 15 years, there's been a measurable increase in the 2-inch, 3-inch, and also 4-inch per day rainfall events. So those different metrics, those different thresholds, we're finding increases in all of those. And across the broader Northeast region, there's been a 55% in annual heavy daily precipitation as well. So it's not just in the Northeast, although it's increasing the most in the Northeast region in terms of the rest of the country. And so we are definitely feeling that here. Now, there's also, in the last 20 years, there's been an increased likelihood of what we call blocking patterns in the atmosphere. This picture, the jet stream doing a big loop, kind of like that. This is an image showing temperature departure from normal. Red's warmer than normal, blues cooler than normal. This is for the day average, October 31st, right before this past November 1st storm that caused, I think it was a couple 100,000 power outages across the state, which came after, about 2 weeks after another very similar storm that had I think the heaviest impact was in southern Maine for that one. But part of what is tied into these storms, or how they're developing, is that there's been a increased likelihood of large wave patterns getting locked into place for a few days, under which a heat wave or a cold wave can develop. And that situation produces really steep temperature gradients, which can fuel strong storms, is the long story short. And so the extreme weather, much of that is linked to changes in atmospheric circulation. And that, on an even larger scale, research suggests that it ties very strongly into the warming Arctic. All the mechanisms for that are not known for certain, other than the Arctic has warmed more than any other place on the planet, and it has an impact on the whole northern hemisphere. And we have observed a change in circulation as a result of that. This is an example I like to show. This is always stuck in my mind because third week in March 2012, as some or many of you may recall, it got into the 80s in March. And I happened to be at UMaine Farmington giving a talk on ice ages on the day that the temperature was 83 degrees. As I note here on the slide, on that day, March 23rd, the temperature record for that day in Farmington was set by 17 degrees Fahrenheit. And there is no historical equivalent to this particular event. But as you can see in the upper panel, there's a large blocking feature, and here's a temperature anomaly. Massive high pressure that set in for several days over the middle part of the continent, and that eventually moved our way, and bringing those very high temperatures to our region. But this is an example of an extreme event, and also an example of the lengthening summer season, because this was summer-like temperature and humidity in March in Maine. And so as the climate continues to warm, we expect to see more incidences where in the spring and in the fall, it seems like the warmer weather is persisting. That's my son from several years ago. I told him, I'm sorry, I don't have any snow for you right now. And that leads into this. Maine snow is melting earlier. Although there's still significant variability from year to year, the overall shift is a downward trend in the winter snowpack. And by about 7 to 14 days, in terms of the melt-off, the melt runoff in the late winter, early spring, that's about 7 to 14 days earlier on average. And also ice out. I think we've all noticed that lakes tend to ice out earlier in the year. And they also the ice forms later in the fall, early winter than it used to. And so this figure here shows sites from 1934 to 2008 across the state, and indicating number of days earlier in comparison to the early baseline. And that again is on the order of a week earlier ice outs. And 2012 and 10 near record ice outs or record ice outs on many lakes in the southern half of the state. There's also an increasing magnitude and frequency of small floods. That's something that's very important, and that's linked to the increased heavy rainfall events. And the last point I'd like to make is the 100-year flood events. That's the 3-day peak flow, which is a 1% chance of it happening in any given year. That is projected to decrease, likely as a result of diminished late winter snowpack. And with that, summary of the points. I've included this in the slide for those who download the presentation and would like that, but it's also going to be in the document that we publish. And thank you very much.